Hi, everyone. Thanks for coming. Adorable as these monkeys are, we have a different agenda for today. So welcome and thanks for coming to this talk on Xamarin, C# everywhere, using C# to build Android, iOS, and Windows Phone mobile applications. My name is Sasha Goldshtein. I live in Israel. I'm the CTO of a company called Sela Group. I'm a Microsoft MVP, and actually I'm a C# MVP. And up until a year or two ago, I was doing lots of stuff totally unrelated to C#, which is my MVP expertise. But now that Xamarin has become available and more popular and more widespread, I'm actually doing lots of C# work in non-standard environments, such as the iPhone and Android devices, as well as other mobile platforms. So in this talk, the plan is to spend the next an hour and a half or so building a couple of mobile applications using a couple of different approaches, but in both cases sharing as much code as possible across all the platforms that we're going to target. And we'll start with the more traditional Xamarin-based approach, which has been available for about 3 years now, and you can use it to achieve pretty perfect code sharing, 90–95% of code sharing, but you still have to build a different UI for each platform. But then we're going to talk about a new technology that Xamarin just announced a couple of months ago called Xamarin Forms, which lets you share 100% of the code in many cases, including the UI layer itself. So you can build UIs that will automatically adapt to whatever platform you're running on. We'll talk about the advantages and disadvantages of Xamarin as well, how to handle platform differences. So there's a bunch of stuff in this talk, some demos and some theory. If you have any questions, please just feel free to ask. And of course, at the end of the talk, if you have anything else you'd like to discuss, I'll be here. I also have another talk in the afternoon, and I'm flying home tomorrow. So if you got any questions, I'll be happy to help today. So let's just get started. My assumption, sort of, is that everyone in this room is a mobile developer in one way or another. Maybe you've already built a mobile application. Please, would you raise your hand if you have? Okay. Maybe you're planning to. Maybe someone's forcing you to build a to build a mobile application. And even if you're building websites and you've got people on mobile devices accessing your websites, you could say you're a mobile developer as well. You have to cater for that audience as well. And what we're going to do is really see how you can leverage your existing C# and .NET skills, which I assume most of you have, to build mobile applications in a more familiar way than if you had to learn Objective-C and Java and the Android specifics and the iOS specifics. And of course, code sharing is a pretty big advantage of using C# with Xamarin, as we'll see throughout the talk. So what we're looking for really is kind of the combination between the best user experience you can get and the best developer productivity that you can get. And there's a number of solutions across the spectrum here. So on one end, you've got native applications. You can build an iOS app in Objective-C and Xcode. You can build Android apps using Java and Eclipse. You can build Windows Phone apps using C# and Visual Studio. And then your developers are in a pretty bad shape, and you, as the developers, are in pretty bad shape. You have to learn 3 totally different platforms, paradigms, and environments. And you're dealing with unique problems on each platform. Plus, you're probably not sharing any code, unless you're willing to do C++, in which case you can share code, but then it has to be C++ code. So that's one option, native development, and you get a pretty good user experience on the other hand, but developers are suffering pretty badly. And I'm saying this as a developer who actually built iOS and Android native applications, so I know the tools, I know the languages, but I also know it's unreasonable to expect everyone to learn 3 different platforms and languages to target 3 mobile platforms. The other end of the spectrum, we have web or hybrid applications, and then you only, and I'm saying only in quotes here, you only have to learn HTML, JavaScript, and CSS, and you have an app, or at least a mobile website, that will look decent on most mobile platforms. And that's partially true for very simple applications. But as soon as things get a little bit more complex, you find yourself writing native code and adding plugins to your HTML application and building different layouts, different HTML pages, different CSS style sheets for different platforms. And so at the end, it might be a pretty bad mess anyway, even though you started out with a lot of shared code. And the other problem is the end user experience. And it's a pretty well-known story of how Facebook sort of decided to move away from HTML5 for their mobile applications and go with native. It's not supposed to convince anyone, but it does show that in particularly high-performance scenarios where a really good user experience is necessary, you might sometimes find it impossible to achieve the result with just HTML. And then as soon as you start adding native components to an HTML application, you start losing all the advantages of cross-platform development with HTML. And finally, Xamarin, which is the focus of our talk today, is at least designed to put you right in the sweet, proper spot of combining the best developer productivity, because you're using just one language and one development environment, and that's C# and Visual Studio or Xamarin Studio, and you're getting the best end user experience because the final application has the same performance, or at least almost the same performance, as a native one. Because you're not building HTML pages that show up in a web view, you're actually using the platform APIs, but you're doing it from C#. So that's the premise, that's the promise also of Xamarin, and that's what we're going to look at today. So the Xamarin approach means you're writing fully native applications which are compiled down to the target platform, not running as HTML and JavaScript, but you're writing them in C#, which is pretty nice considering most of us are C# developers. You can use your favorite IDE, and having worked with many mobile development environments, I'm pretty convinced at this point that Visual Studio is the best IDE ever conceived and built. And so you can use the Visual Studio Designer to design the user interface. You can, of course, use the editor and any plugins you have, ReSharper or whatever. And you can use the Visual Studio Debugger to debug mobile applications running on an iOS device or running on an Android device, running in a simulator, an emulator, and so on. You can access 100% of the native platform APIs with Xamarin, which is what makes it so different from HTML apps, like from HTML platforms like PhoneGap and SenchaTouch. Using Xamarin, you have 100% API coverage. So your C# code can call exactly the same APIs that a native application can call. So if you find a snippet of code on Stack Overflow saying, to do this really subtle thing with the accelerometer on an iPhone, you have to call this function, and the code example you get is in Objective-C, you can use that. You just write the same thing in C#. You use a different syntax, but you use the exact same libraries and the exact same APIs. And so far, Xamarin has pretty much lived up to the promise of delivering full API support the day a major version of iOS or Android was released. So as soon as iOS 8.0 was finally released, Xamarin also released the same day support for all the iOS 8 APIs. And this is something they've been doing pretty much for the last 3 years. And finally, you can share code, of course, across platforms, assuming you're building a multi-platform, a cross-platform application, using shared code, using shared links to C# files, which I would probably discourage, or by using shared libraries, which are, in our case, PCLs, Pickles, Portable Class Libraries. I hope you've heard of the term. Portable Class Libraries are libraries that contain .NET classes, which can be used from different platforms. So you can use a PCL from iOS, from Android, from Windows Phone, from Windows 8, from a WPF application, from ASP.NET applications. It all depends on the set of platforms that you configure your PCL to support. So by using PCLs that are compatible with Xamarin, you can build shared logic, shared components, and you can also find lots of shared components existing online on NuGet, for example, and you can use them from all your different platforms, from all the different applications. And so again, the holy grail here is where you just have these little tiny projects for iOS and Android and Windows Phone and Windows 8, which are all accessing the same big library, which contains all of your actual code. So you only have these tiny projects that produce a build you can install on devices, but your code lives in a shared component, in a shared library. And that can pretty much be our reality with Xamarin. And so with Xamarin, you can bring your C# code to roughly 2.6 billion devices. And this includes iPhones, Android phones, Windows PCs, which could already run C#, of course, and Macs as well. It's not something we're going to cover today, but you can also use Xamarin to build Mac, native OS X applications, as well as iOS apps. Again, using C# and sharing lots of the logic between the platforms. And so 2.6 billion devices is a pretty appealing proposition. And let's just talk a little bit about how Xamarin works before we get to a demo where I build a simple Android application using Xamarin. And then we'll go to iOS as well. So the idea is you get 100% bindings to the native API, provided again by Xamarin, provided by their framework. And it's pretty similar to how interop works in .NET on the desktop, on the server, when you call from C# to C++ code. There's the pinvoke layer. The pinvoke layer provided by the .NET runtime. Xamarin provides their own interop layer for calling from C# to iOS code, for calling from C# to Android framework code. So again, from your perspective, you're just calling a C# function, you're using a C# class that wraps an existing API. And of course, there is this tiny little bit of overhead. Anytime you're doing interoperability, there will be a tiny little bit of overhead. But it's really minor in most cases, especially when you're dealing with the UI, when you're calling file APIs, database APIs. As long as we're talking about thousands of method calls per second and not hundreds of millions of method calls per second, you're going to be fine with this overhead of the interop layer itself. So this is one area in which you're getting slightly different performance than in a native application, but it's really not an area of concern from my experience at least. The way Xamarin works on Android and iOS devices is that you get a .NET runtime packaged up and installed as part of your application. So you get a garbage collector. On Android, you get a just-in-time compiler, you get the reflection engine, you get serialization, you get all the services provided by the .NET runtime and by the .NET framework packaged up as part of your application. And this is another thing I'm going to mention towards the end of the talk as a disadvantage. It does make applications a little bigger. Because an iOS app, excuse me, that you build with Xamarin has to ship with the .NET runtime so you can install it on the user's device. And Xamarin have taken lots of aggressive optimizations there to only ship the parts of the .NET framework that are strictly necessary, but still Xamarin applications tend to be a little bigger than a completely native app. So that's another area where there is a slight difference. And as far as compilation goes, on iOS, because iOS actually prohibits dynamic just-in-time compilation, on iOS, Xamarin apps are compiled down to native code at build time. So when you compile your app in Visual Studio, it ends up as a fully native piece of code. On Android, Xamarin actually uses a JIT compiler, just-in-time compilation, because Android does make it possible to do just-in-time compilation, and actually Java code that runs on Android is also compiled at runtime, also using a just-in-time compiler. So this is not a particular area of difference between the different approaches. And finally, in terms of tools, just to whet your appetite, Xamarin have an IDE which you can actually get for free called Xamarin Studio. And it's a cross-platform IDE that you can use on a Mac and you can use on Windows. And it has the same solution and project file format as Visual Studio. So you can have Mac developers using Xamarin Studio on the Mac, and you can have Windows developers using Visual Studio on their Windows, sharing the same projects and sharing the same solutions. So that's really, again, appealing. But you can also use a Visual Studio extension that Xamarin provides, and then you get the full benefits of Visual Studio, which you're probably accustomed to, and still build iOS and Android applications, compile them, debug them, deploy them to devices, all from within the comfortable Visual Studio environment. And of course, Visual Studio requires Windows, doesn't run on a Mac, and there is also a slight issue with building iOS and Mac applications with Visual Studio. Turns out Apple doesn't like us building iOS and Mac apps on Windows. And so Apple requires a Mac build host to compile an iOS or OS X application. And so even if you are using Visual Studio for that, you will need and OS X, a Mac build host, just for that final compilation step. And again, Xamarin have pretty much gone out of their way to make it easy to set up a pairing between your Mac build host and your Visual Studio environment, but that's a tiny pain point that doesn't really depend on Xamarin's choices. It's all down to Apple's restrictions on building iOS applications on anything that's not a Mac. But other than that, you're pretty much in Visual Studio in all the comfort of that IDE. So having talked a little about the theory of Xamarin development, I want to show you a couple of apps, screenshots from apps that demonstrate that you can use Xamarin to build real, impressive applications, and then we'll get down to building our own little app. So on the left, there's RDIO, which is a pretty popular app built entirely in Xamarin for Windows Phone, iOS, and Android. This thing over here is an app for Bosch Siemens customers, which they can use to review product manuals and find service centers. And here on the right, there's Kalka, which is a pretty awesome sort of math notebook app, which you can use to embed calculations inside a little notebook, share that thing with other people. So what I'm trying to say is that there are lots of Xamarin apps in the stores already, the iOS App Store, the Windows Phone Store, the Android Store, using Xamarin to deliver cross-platform experiences. If I was giving this talk 3 years ago, I'd say Xamarin isn't quite mature. You should probably consider waiting for other people to submit their apps and see what happens. Today, I can pretty much safely say that for most kinds of applications, Xamarin is pretty mature enough, and you can definitely use it to build and deploy apps in the stores, in the actual production stores. So let me show you what the process looks like, and I'm actually going to use Xamarin Studio. The reason is I'm using two virtualization platforms which are incompatible with each other, but I could do this whole demo in Visual Studio as well. I think it's also a good opportunity to experience with something a little different and also see how Visual Studio is superior, actually, to anything else. So what we're going to build is a simple Android app at first, which accesses a very, very simple web API. This is just a chunk of JSON that I'm getting from the internet, and it has a list of sessions and speakers at a certain conference. And we're going to parse that and display it in our application's UI. So I've already got a portable class library called sdp.shared, which has a couple of classes, session over here, which describes a conference session with a title and description. And I've got a speaker class, which has a list of sessions and a name, a bio, a blog, a Twitter, a photo URL. And finally, I've got a class which actually contains most of the business logic for this application called API service, which is responsible for talking to that backend service, retrieving JSON, parsing it, and producing objects. And the code here doesn't use JSON serialization. It just sort of manually parses the JSON results. So there's a bunch of code here that produces a list of speakers and a list of sessions, and it's not really all very interesting. What is interesting is that the code here is actually portable. So I can use it from Windows Phone, I can use it from Android, and I can use it from iOS. And if you look at the references, the NuGet packages that this portable class library depends on, you'll find Microsoft.NET HTTP, Newtonsoft JSON, Microsoft BCL, Microsoft BCL Build. These are NuGet packages which are in turn portable class libraries. So you can consume them from all the platforms that Xamarin supports. So as long as you're building your code in a portable class library and you're only using other portable class libraries that support all the platforms you want to target, there is no reason for code duplication. You just build the whole thing once and you can consume it from all the different platforms. And that's exactly what I'm planning to do here. And again, the service isn't particularly interesting, so we'll focus on building the actual application. So I'm going to add here, a new project. And the project kind I want is an Android application. And I'm going to say Android application over here, and we'll call this thing sdp.android, and click OK. And so we have an Android project now. And down here under Resources Layout, you'll find, OK, that might be a problem. You'll find an Android AXML file, which is what we design our user interface in. So Xamarin Studio, as well as the Visual Studio extension, ship with a designer that you can use to build your Android UI. And I can also edit this thing by hand if I just open it in the source code editor, or maybe not. Well, anyway, I'll show you a built-in, a pre-built demo in a second. But there is a visual designer, and there's, of course, an XML editor, because it is just an XML file. In addition, I've also got a C# class over here called main activity. Activity in Android is pretty much the same as a screen, a form, a page. So this is the main code behind file for that layout file that you have just seen. And again, it's all C# code. So I'm just going to get rid of this AXML file and try to build the whole UI from code just for our demo to work. So trying to delete the file. This spinning rainbow is Mac's way of saying something's taking a bit longer than anticipated. Delightful. Okay, I'm going to bring in Activity Monitor and kill Xamarin Studio. That's a good start, you know. So force quit, ignore. And now the error report window is not responding. This is awesome. Okay, Xamarin Studio, starting it up again. And I'm going to load that solution over again. Okay, so here's the SDP Android project. And here's our activity class. And let's see if the layout file, yeah, okay, it's not there anymore. So I'm going to remove it from the project. Great. So in this activity class, I'm going to delete most of the code, actually all of the code. And in this onCreate method, I'm going to create our UI from code. And that's just because the designer, as you've seen, doesn't seem to be working because I have an outdated version of the SDK. It doesn't really matter for our purposes. So the UI component we're going to use to display the list of speakers and the list of sessions is called a list view. It's an Android component, which is pretty similar to a WPF list view or list box. And I'm going to call it list speakers. Create one, and I'm going to call set content view to say this is the UI our screen should show. So this is the main UI element. But of course, we still need to bind it to some data. So I'm going to need me an array adapter of speaker, and speaker is that model object which lives in our shared portable class library. So it's probably time to add a reference to that shared project from my Android project. Okay, and now the speaker class should be something I can resolve with a using statement. So an array adapter is how we bind a collection of speakers to a list view in Android. Again, it's a purely Android concept, so I'm not focusing a lot on it here. Xamarin is just wrapping classes that you would use from a Java application as well. So I new up an array adapter of speaker, which takes a few parameters. A resource here would be android.resource.layout.list, simple list item 1. And the final parameter is a list of speakers, which we retrieve from the web service. So this is a list, just a plain list of speakers. New list, got to import. You see why Visual Studio is a superior development environment? So resolve system collections generic. And where do we get that list of speakers from? Well, we have the API service, which has a convenience method called getSpeakers. Now, getSpeakers actually returns, if you look at it, returns a task of IEnumerable of speaker. So it's an async method. And the amazing thing that Xamarin have done is that they let us use async and await on Android and iOS. And Objective-C, by the way, and Java have nothing like async and await. And so it's really incredible that we can use these C# features on platforms that totally don't support this. So essentially, over here, I'm going to just await API service getSpeakers, right? Now, of course, I can't use await in a method that's not an async method, so we're going to mark our own create method as async. Okay, so the final thing we have to do is just tell our list speakers object that its adapter is this adapter I've just newed up. And if everything went well, we're supposed to see a list of speakers on screen. And here's an Android emulator that I've got running. And let's try to run our app on that emulator. So set a startup project and just play. Okay, so the first launch, by the way, is going to take a little long. As you can see here, detecting packages, waiting for packages. Well, actually, it wasn't that long, was it? And here's what we get. A list of speakers. I promised you a list of speakers. That's what we get, a list of speakers. So we're missing a data template, right? If this was a WPF application, you'd say, of course, we need a data template to display speakers. So for now, we're not going to use data templates because Android doesn't have data templates. What I am going to do is just override the toString method on the speaker class so that it returns something I can bind to the UI. So we're going to override toString. By the way, it did generate a very long string format call, but I'm just going to return the name. Okay, if we run this thing again, we're supposed to see some speaker names. Okay, yep, there it is. So we've got some speakers showing up in our amazing Android application. That's going to be enough for now anyway, and we have, with a little code that handles only the UI aspects, we have a display layer for the Android application. Most of the code is living in that shared portable project, sdp.shared, which will be shared as soon as we add an iOS application as well. So let's just go ahead and quickly add an iOS application. And I realize it is all very, very simple, but that's what we have time for. Towards the end of the talk, I'll show you a canned demo, which has more features, and it's going to be a little faster. So iOS, classic API, iPhone. Let's make it a single view application. Call it sdp.ios. Okay, so we have yet another project in our solution. I'm going to make it the startup project. Well, I'm going to make it the startup project. Can't seem to make it the startup project. Anyway, I can run it just to make sure the whole compilation step succeeds. And I've already got an iOS simulator sitting over here. Okay, we get a build error. iOS team provisioning. Oh, it's trying to build for the wrong platform. So debug iPhone simulator. Okay, so something's terribly wrong with this. There we go. Okay, and I'm going to choose iPhone 6, iOS 8 as my target, and just compile this thing again. It was trying to build for a device which requires a certificate that Apple provides. So anyway, in the iPhone simulator, we now have an empty iOS application. Not particularly interesting, but it does seem to be working. Now, in this particular case, the code we're going to be writing sits in this class over here called SDP iOS View Controller. Pretty bad naming. We can obviously change the name, but this is the code behind class for the main screen of that iOS application that we're looking at right now. And the designer view is over here in this file called main storyboard. So as you can see here, the designer did work, unlike the Android one. We get a nice visual surface where we can drag and drop controls. So I will drag and drop a control called a table view, which is one of these guys, UI table view, right over here. And I'm not going to particularly care about positioning. We can talk about layout in another talk. There are, of course, ways to build Android and iOS apps that resize dynamically according to the size of the screen, but we're not going to bother with that for now. So we've got this table view thing, which is just like an Android list view. Again, it can display a dynamic number of items. And we need to make this table view available to our code behind. So, okay, let me just drag to the view controller. They've changed the designer. Let me just drag to the view controller over here. It's supposed to display, man. Okay, let me just do it from code again, I'm sorry. Okay, so going back to the code, let's get rid of did receive memory warning and of view did load and view did appear and the view will disappear and view did disappear. We don't really need all of that. We just need view did load, where I'm going to create a table view from code, add it to the UI, and get some callbacks so I can populate the display. So we create a UI table view. Let's call it table view, new UI table view. It needs a frame, and I'm going to use the existing frame, so it takes up the whole available screen space. And I'm going to tell my view, add view, add subview. What's that? Yeah, view, add subview, table view. So this table view now becomes the root of the hierarchy. And I'm going to tell the table view that its delegate is me, and that its data source is me as well. And this is a weird pattern that you'll see on iOS a lot if you've worked with iOS before. UI controls that need data often call back to your objects to get that data. So that's what we have here. I'm telling the table view, you can call back to me to get data to display. Actually, I don't need the delegate, I just need the data source. My class needs to implement UI table view delegate for that. UI table view data source for that to work. And that interface, UI table view data source, has a couple of methods we're going to not override, we're going to implement. And specifically, we'll need, let's just navigate to this. Go to declaration. Specifically, we need UI table view data source. Yeah, so we need rows and section, and we need get cell. Wait, what? Okay, sorry. I'm going to use an existing object for that. So a new class. New speakers data source. Sorry for that. And I'm going to inherit from a class that already provides all the services I need. So just going to create a class over here, which inherits from UI table view data source. And then I got to override just a couple of methods. Number of sections, which is how many grouped sections I'm going to have in that list. And yes, it's a lot more complex than doing the same thing on Android, but that's life on iOS. And I'm going to override number of rows in section, or just rows in section, which asks me how many rows are in that one section I have in my table view. So as soon as I have a list of speakers here, not NS property list format, just a plain list, as soon as I have a list of speakers here, I could just return speakers.count. And finally, it's going to ask me for get cell. And here I'm supposed to return the row for each element that I have in my table view. So this I'm going to leave for a second. Let's just resolve list. And let's add a reference. Let's add a reference to our existing shared portable class library. And by the way, you'll notice that Xamarin Studio prevents me from adding a reference from the iOS project to the Android project, which would be an obvious mistake. It only lets me add references to portable class libraries. Okay, and then I can resolve the speaker class as well. And when this object is initializing, when speaker's data source is initializing, suppose we create a static method here called create, and add a private constructor, which would populate this list of speakers with API service get speakers. And this thing is actually asynchronous, and I can't make the constructor asynchronous. So let me put it in this method, which I can make asynchronous. Okay, so I'm just going to get a list of speaker here. And this thing over here, I'm going to make a public property, actually, so I can initialize it easily. So it's got a getter and a setter. And now I'm returning a new speakers data source with speakers equals speakers. Okay, that looks about fine. And over here, just say speakers. Okay, so something like that. Again, async. Everything's async. And when we get to get cell at last, this is where we provide the UI for each row in that table. So I'm going to new up a UI table view cell. And I need a frame. So actually, I'm going to ask the table view, the queue reusable cell, identifier my cell, UI table view cell cell. That's the cell I'm going to return. And now I should put some text in that cell, in that row, and the text is just the speaker at indexpath.row.name. So we want to display the speaker name. Again, I realize it's a lot more code than the Android version, but that's the way you would actually do it in an Objective-C iOS application or a Swift iOS application. That's the way you bind a table view to a data source. It's pretty nasty. Coming back to my view controller, instead of new over here, I'm going to have to await speakers data source dot create, which makes this method async. And that's pretty much it, I think. Yep. Okay, so let's try this thing. Just going to stop what's running already and run it over again. Okay, the return type of an async method has to be task of whatever. That does make sense. Okay. And what this returns is actually an IEnumerable. So I got to create a list from that IEnumerable. Okay. Well, it did compile, so it must be working. Okay, there we go. Object reference not set to an instance of an object. Cell is null. Yeah, the table view isn't giving me a cell. So I'm just going to go, right, okay, let's, the reuse identifier is in the storyboard, and I'm not using the storyboard. So let me just create a cell with a new frame, and let's make that thing 0, 0, width 400, height 40. Okay. It's going to be pretty ugly, I bet. Yeah, okay. Pretty ugly, but we do get a list of speakers. There is a tiny, teeny issue with margins here. The topmost cell is really tightly aligned with the status bar, and so it looks pretty bad, but that's a UI design issue. I'm going to totally disregard that. But in any case, we do have, after some effort, a simple iOS application that displays the same information. And again, there is quite a bit of code here, but it's UI code. It's UI and UI glue and binding stuff. It's not business logic. And in a real application, the UI binding and glue code would really be a smaller part of the code compared to the shared logic that you can use. But still, the situation isn't perfect. And we'll see in a few minutes how Xamarin Forms makes this whole thing better. Because right now, we've just built two completely different UIs. And of course, it could be a good thing. Could be we really want a totally different display for iOS and for Android, but it's probably more likely that we just need minor platform tweaks and the general appearance of the app should be the same. And if we want the general appearance of the app to be the same, we're really writing a lot of code to make that happen, which doesn't seem cross-platform at all. But at least we're doing it in C#. At least we're doing it in Visual Studio. I'm not using Visual Studio, but it could as well be Visual Studio. And at least we're sharing the business logic. At least we're sharing that code that accesses the web service and does the HTTP and JSON parsing. So that's it for this demo anyway. We've built a simple Android app. And as you've seen, the code sharing we've been able to achieve so far requires that we have a shared portable class library that contains most of the logic. And then we build, in each platform project, we build a user interface layer for that platform. So we have an Android UI, we have an iOS UI, we have a Windows Phone UI, and each platform has a different set of view code. And so again, in a real app, we might be able to get up to 90% code sharing in that shared layer, but we're still building a view for each platform. And there is another area which would probably require duplication for each platform. The shared PCL layer doesn't give you all the APIs you could expect. For example, you noticed there was a NuGet package which is cross-platform for HTTP and for JSON serialization and parsing, but there isn't a shared portable NuGet package for accessing location on the different platforms. So suppose you need to access the user's location on iOS, on Android, on Windows Phone. The best solution you have is that your shared platform code, your shared PCL, depends on an interface, say iLocation provider, and then you use some sort of dependency injection so that the Android layer, the iOS layer, the Windows Phone layer provides a concrete implementation for that platform. So on Android, that interface would be implemented using the native Android location APIs, on iOS using the iOS native location APIs, and so on. And so again, this does produce duplication. The shared logic depends on information that you can only get using native APIs for that platform. Now, hopefully, in some cases, you would find on NuGet a portable class library which you use, which you consume as a portable class library, but inside it has platform-specific implementations. So someone would already have gone and made the effort of wrapping the necessary logic with an interface and implementing that interface for all the different platforms. But occasionally, you'll find that you have to do it yourself. And in those cases, again, there will be some code duplication. Not really duplication, but implementing the same feature multiple times on multiple platforms. And that's kind of annoying, but we'll never get to a point where all the APIs on all the platforms look exactly the same and you can just consume them directly. Every platform has slightly different features and functionality, and so you will always need some sort of solution like that. And we'll see a very specific example of using this kind of dependency injection pattern for sending email. The code I'm going to show you later offers the user to send a list of conference sessions to their email address, or really to anyone, and there isn't a portable class library that can send email on all the different platforms. So we're going to end up implementing an email service for Android, an email service for iOS, and consume that from our shared code. So there's always going to be a little piece of native code, or at least native APIs in our app, but hopefully we'll strive to make it as little as possible. So I've actually already added an iOS app in the preceding demo, and so I'm just going to skip over and talk a little bit about Xamarin Forms, and then show you a bigger demo where we share a lot more code than what I've previously shown you. So there's two options for sharing even more. For sharing UI logic, for sharing view models across different platforms. One is new, and that's Xamarin Forms. And I'm going to focus on Xamarin Forms. I'm going to tell you all about it. Xamarin Forms is a framework which lets you write the UI layer once and run it on all the different platforms. We'll get to that. The other option is a lot more mature, but it's not an official Android component. It's an open source project called MVVM Cross. You can find it on GitHub, along with a bunch of nice tutorials showing exactly how to use it on the different platforms. And it provides a sort of MVVM-like UI layer that you can use on Android, on iOS, and of course also on Windows Phone, on Windows 8, in WPF applications. Anywhere you can use MVVM, data binding, commands, these XAML concepts. And so MVVM Cross is a really appealing approach if you're not going to use Xamarin Forms in your Xamarin applications. You can use MVVM Cross with the kind of app I've just built to minimize the amount of platform-specific code you'd have to put in your projects. But I'm not going to show you MVVM Cross. I personally firmly believe that Xamarin Forms would be the way to go, and so that's what I'm going to focus on in the demo. And to show you some of the basic concepts, I'm going to create a very simple Xamarin Forms application just to give you an idea of what it's like. And then we're going to look at a demo, at a canned solution, which uses Xamarin Forms with a lot more functionality. So just to give you a quick introduction to Xamarin Forms, I'm going to close this solution over here and just create a new solution. Under mobile apps here, I've got a blank app, Xamarin Forms Portable. Just going to call it Forms Demo. And so what the wizard has generated for me is actually 3 projects. A portable class library called Forms Demo, which has a package dependency on a NuGet package called Xamarin Forms. So this is a PCL. It can be used from Android, from iOS, from Windows Phone. And I also have 2 platform-specific projects for iOS and for Android. So pretty much the same thing we've built in the previous demo, right? Now, the thing is, unlike the previous approach, the UI layer is also going to live in the PCL, in the shared portable class library. So we're not going to have a separate UI file for Android and a separate UI file for iOS. And if you look closely, there is no UI here at this point. So I'm just going to go ahead and add a new file. And under Forms, I've got content page and content view. A content page is kind of like a WPF window, a Windows Phone page, and a content view is kind of like a user control. So we're going to go with a page for now, and I'm going to call that main page. And lo and behold, we have a XAML file. Right? So we have main page.xaml. And this does mean that Xamarin Forms brings XAML to iOS and Android. Right? We have iOS and Android projects consuming a shared PCL, and there's a XAML file in that shared PCL, so it's got to be working somehow. And indeed, Xamarin Forms is a lot about bringing XAML to iOS and Android. So you can use XAML, which is a pretty good, decent UI framework on iOS and Android devices. Now, the unfortunate thing is, it's not exactly the same XAML. So if you've used the Windows runtime on Windows 8 or on Windows Phone, you know it's not exactly the same XAML as WPF. If you've used Silverlight, you know it's not exactly the same XAML as WPF. And it's not exactly the same XAML as the Windows runtime as well. So we already have 3 XAML flavors. So now we have a 4th XAML flavor, and that's the Xamarin XAML flavor. I can't say I'm very happy about it, but it's still better than a totally different UI paradigm, right? At least it's XAML. At least it's recognizable for XAML developers. So let's take a look at that file over here. Does look like XAML. Doesn't have a designer for now. So we got to write XAML by hand. And obviously, there will be a designer at some point in the future, but Xamarin Forms is really brand new. And so for now, we have to write XAML by hand. So I'm just going to give you a very, very simple example. Just going to put a label over here with text equals hello world, and font bold large. Okay? and that's it basically. Just going to run this on Android and on iOS. So let's start with iOS. And while it's compiling, I'll pour me a glass of water. Okay, so yeah, it says hello forms and not hello world, because after creating this XAML page, I haven't actually linked it to the rest of the application. So if I go to the app.cs file, again, in the PCL, in the portable class library, you'll notice it returns a new content page, and that's not what I wanted to return. I wanted to return a new main page, which I've just built. Okay, so try this again. Okay, and this is our label. Again, the positioning could be more favorable, but it does say hello world. And let's try the same thing on Android now. I'm going to make the Android project our startup project and run on the Android emulator. Coming up. Okay, and there's the text, hello world. Again, it was obscured by the status bar, but it was there. So at this point, hopefully, you see that there is some interesting potential here. We can create XAML files once and run them on the different platforms. And of course, there might be some tweaking. We might want to tweak the appearance for the different platforms. Maybe margins, padding, positioning, font sizes, font selections should be different. But the general UI design would probably be the same. And that's what we get from this shared XAML file. And it has all the necessary prerequisites for MVVM. For example, it has data binding. So if I go over here and create real quick just a plain empty class called main view model. And in that main view model class, I implement a simple property called text to display, which returns hello from view model. Okay? And of course, I don't need this empty constructor here. And now, if I go to the main page.xaml, I can just go ahead and say that the binding context for that content page, oops, should be over here. The binding context for that context page, and binding context is Xamarin's way of saying data context. They have a different convention. So this thing should just be an instance of my main view model. And of course, I'll need an XML namespace for that. So let's just align this over here. And I'm going to say XMLNS local, CLR namespace, what was that? Forms demo, assembly, forms demo. By the way, you'll also notice that there is hardly any IntelliSense and autocompletion in this XAML editor. Again, it's all pretty new, this whole technology. So now that we have a binding context, I can say over here binding text to display, which would be retrieved from my view model. Okay, let's try this on iOS. It's just a little faster to start. Okay, loading, and there it is, hello from view model. So we can use data binding on Android and iOS. Again, pretty crazy considering what we had to go through previously to get some text on the screen on iOS and Android. And this, by the way, is just one side of MVVM. This is data binding. The other side is commands, and Xamarin Forms also supports commands. Not every control I'd like supports commands at this point, but enough of them do to build simple UI experiences anyway. The reason I was even showing you the other approach, building a separate UI for iOS and Android, is exactly this. It's not quite there yet, right? There is no designer, there is no IntelliSense, there is no auto-completion. Not all UI controls are implemented, so there's a bunch of stuff missing. But this is definitely the future. I mean, who wants to build different UI views for different platforms if they all should look pretty much the same with minor tweaks, right? And this is what Xamarin Forms will be about. So let me show you the same SDP application, this conference application, which I've already built with Xamarin Forms. So first of all, let's take a look at the shared project here, SDP Forms. It's got the familiar API service, the conference service, which retrieves speakers. It's got two XAML files, 2 pages essentially, a speaker page and a speaker details page, which shows information about a specific speaker. There is a speaker view model here with commands and data binding. I'm not going to go over all of this. So first, I'm just going to run the app, show you the end result, and then discuss a couple of interesting points concerning Xamarin Forms in this application. But the important thing to notice here is that the Android and iOS projects do not contain any UI code at all. The only thing that's actually implemented twice is the email service over here, and we'll come back to that. So let me just real quick run the iOS app just to show you the basic functionality we've got there. And again, the UI itself is entirely cross-platform. Okay, so it's asynchronously loading the list of speakers, and it's got a list of speakers with photos and the number of sessions. And so if I click Ido, who's a fellow speaker here, we got a picture and a bio and a list of sessions. And if I click a session, it shows a little pop-up with the session information. And this button over here is supposed to open the email application and let me send Ido's sessions to someone else. Now, the simulator on Android, on iOS, doesn't actually let you send email. So if I click this button, you'll see a mail show up, but the body doesn't show, and it's just hanging there, and it's going to crash in a few seconds. So that's not my app's fault. It's just the way the simulator works. If I run this thing on Android, on the Android simulator, we're going to get a pretty similar UI, but themed for Android, naturally themed for Android, and with exactly the same functionality though. So here's the main page, and the speakers are loading. There they are. Now the fonts are a bit different because that's the platform defaults. On Android, the platform defaults are a little smaller, and that's also, by the way, because of the huge resolution this device, this emulator, is running under. If I click Ido again, I get this detail page with a bio and a photo and a button and a list of sessions, and it's all themed again for the target platform. So it doesn't look exactly the same, and it shouldn't. It should look like an Android application, while the iOS one should look like an iOS application. So again, for simple UI controls, this native theming is very appropriate. And again, here if I click email session, it's going to ask me how I want to send those sessions, because on Android, I actually don't have to commit to sending via email. I can just say, send it, and whatever way of sending stuff exists would be offered to the user. Now, obviously, I don't have an email account configured in the emulator, so again, I'm not going to send anything over here, but it does show the potential. Now, like I've said, the only thing that's actually specific to a platform here is the email service, the part that actually sends the email. And the reason is there is no portable class library that can send email from iOS and Android applications. You've got to implement it yourself. So this is the interesting part I want to cover. In the speaker details page, I have a button over here. I have a button. This is the email sessions button, right? The text is email sessions, and it has a command that's binding to my view model, to a property called email sessions command. The view model is called speaker view model, and sure enough, it has a property called email sessions command. And to make a long story short, when this command is invoked, what happens is that email sessions, this method over here, is called. And again, that's still happening in the portable class library. The XAML is portable. The view model is portable. The construction of the email body with the HTML text is, of course, portable. The only thing that isn't portable is actually getting the email out to the email application. And so here, we use a nice dependency injection service, which Xamarin Forms provides. So you don't have to bring your own DI container. You can use one provided by Xamarin Forms. It's called dependency service. And so as you can see here, I depend on an interface called iEmailService. I ask the DI container to give me that, and then I call compose email. Now, the service interface lives in the shared class library. The implementations live in the Android and the iOS projects, respectively. So if you look at the Android one first, because it's a lot simpler, you'll notice there's a class here that implements the interface, and there is an assembly-level attribute called dependency, which says this email service class should be exported as a dependency. Kind of similar to MEF or any other dependency injection flavor you might be used to. So this is the Android version. As you can see, it's just 5 lines of code. The iOS version traditionally is a little more complex. And again, email service lives in the iOS project, implements the interface, exports that dependency using the dependency attribute, and it has an implementation for the compose email method. And there's a bit more code here, but again, all it does at the end is show up the native email app and let the user send an email. And this code couldn't possibly be made portable because it's really different on iOS and Android. It's different native APIs. Sorry for that, there is no way around it. But at least we're not doing the UI part twice for each platform, the view models twice for each platform, and so on. So if you look at the, again, at the shared project, at the Xamarin Forms shared project, everything, almost everything is under that shared project. The views, the view models, the business logic, behaviors, anything else really you need to include in your view and your business logic of the application. Whenever necessary, we extract dependencies which have to be platform specific, hide them behind an interface, and implement them for each platform. And the end result is a lot more code sharing, and of course using the pretty convenient XAML and MVVM way of work. So let me just go back to the slides for a moment to talk about some pros and cons before we wrap up. Yes? Absolutely.
Yeah, so in your Xamarin project,
Mm-hmm.
view models and your model classes there.
What's that, sorry?
So in the Xamarin Forms project,
Uh-huh.
and you've got your model classes and your view model.
Yeah.
So if you want to say, for example, factor them to separate class types,
Sure.
Xamarin Forms?
No, it can be a simple PCL. So yeah, I can totally agree with what you're saying, that you probably would have 2 assemblies, one for the view and view models, and one for logic for models, maybe even a separate one for views, for view models, and for models. Totally up to you. And you can use simple PCLs for that. In fact, this is a PCL. It's a PCL that has a reference to Xamarin Forms. Other than that, it's just a simple PCL. So what Xamarin have done is implement a NuGet package that has all the Xamarin Forms UI controls and the MVVM layer, the data binding, all of that. And you're just referencing that PCL, that NuGet package. Plus, they implemented the XAML toolchain, which compiles the XAML file, creates partial classes, whatever is necessary. And hopefully in the future, they will also have a UI designer. So you build the XAML, at least with a preview and auto-completion. But for now, you just write XAML files by hand. Okay, so just to talk a little bit about pros and cons, and then I'm going to leave room for questions. Of course, we have quite a bit of time. So on the plus side, you really write once and run everywhere. Xamarin can make it possible to build XAML shared views that run on iOS, Android, Windows 8, Windows Phone, potentially also on the Mac or on the Windows desktop as a WPF application. XAML now has a much broader field than before. C#, of course, is a great language, and you can use it from Xamarin Studio, from Visual Studio. You can build shared logic that leverages all the existing NuGet packages, which are already portable. And there's probably tens of thousands of NuGet packages that are portable and can be used with Xamarin. And in fact, as an aside, Xamarin has their own component store, which is kind of like NuGet, but they also offer paid components that you have to download for a fee from their store. And again, it's pretty much the same as NuGet. It brings down a bunch of assemblies, but it's a different way of distributing them. So you could also use lots of components from the Xamarin store, from the Xamarin component store, to extend your Xamarin application. You get full native apps by using Xamarin. The end result is compiled down to the native platform. There is almost no performance penalty. There is the slight penalty of doing the interop, of doing sort of p-invokes to the native APIs, but that's usually not an overhead that you should be worried about. Other than that, you're compiled down to native at the end. And you have access to 100% of the native API. So there isn't a single class on Android or a single class on iOS that you simply don't have access to, and you have to write native code to use. Whatever examples you find on Stack Overflow using Objective-C, you can use in C#. You find an example in Java, you can use it in C#. And that's a pretty great proposition. On the minus side, the tools, as you might have noticed, lack some maturity still. And this applies to both Xamarin Studio and to Visual Studio. And I mean, Visual Studio crashes occasionally. It doesn't take Xamarin to crash Visual Studio, right? Pretty much every part of Visual Studio crashes occasionally, but the Xamarin extensions occasionally exhibit maturity issues, stability issues. When new pieces of functionality are released, major ones, such as Xamarin Forms, for a few months, there will be some bugs and instability issues that you typically don't see with the .NET Framework or WPF or the more mature Microsoft technologies. But these are growing pains, and hopefully they'll go away. The other problem is license costs. Today, you can build Android apps for free. Eclipse is free. The Android development tools are free. You can use a Windows machine, a Linux box, a Mac. You can build Android apps for free on every platform. iOS isn't totally free because you need a Mac, but Xcode, the development tool, is free. And you do need an iOS developer account to submit applications to the iOS App Store. But again, the tools at least are pretty cheap or free. Xamarin isn't free. There is a free license that you can use for demos to build very, very simple applications. There is an indie developer license, which also has some restrictions. There is some licensing program for open source projects. But for most purposes, you and I are going to need either the business or enterprise licenses. And these are pretty expensive. These are thousands of dollars a year per developer, usually. And so these license costs add up, and Visual Studio, of course, also has the associated costs. So this is a pain point that I've found when trying to convince stakeholders to move to the Xamarin toolchain. And obviously, you're saving a lot of time on productivity, but occasionally people are hard to convince when they have to pay up front for the license. And lastly, I've mentioned this already, the .NET runtime bloat. Any Android or iOS app that you use Xamarin with ships with the .NET runtime. It ships with the .NET runtime so it can be installed on the device. And that increases application size, increases memory utilization a little at runtime. So you might find for very, very complex applications or for super high-performance games that the code bloat and memory usage still warrant a native app that uses the native language, and not C# and Xamarin. But for 99% of the applications you and I are probably working on, Xamarin is something I would definitely seriously consider. If you already know C#, if you're already used to Visual Studio, if you like the .NET Framework, if you like NuGet, if you like XAML, or even if you don't like XAML, if you prefer building views by hand, still, Xamarin is more compelling than learning Objective-C and Java, at least in my opinion. So we do have a few minutes for questions. Just going to put up my contact slide. It has a link to the presentation. And on my blog, I'm going to put up the code demos as well, after just merging them a little. So you'll have access to all the materials I've used today. If you have any questions, please go ahead and ask. Yes. You've got a mic?
I'm just wondering if you've got any TDD strategies for developing in Xamarin, because I noticed lots of the things that you were demoing today didn't seem to be testable in the traditional TDD sense.
Right. So if you use MVVM in general, one of the core tenets of MVVM is testability. Sorry. And so, yeah, absolutely, you can test your view models pretty much the same. You could test your view models with WPF. I actually, as part of this demo project, I do have a tests project just to show that it's doable. So there is a tests project over here, which is itself a portable class library, and it uses NUnit. You can actually use other test runners as well. And these tests particularly only test the model layer, but you could also test the view models. Now for UI testing, if that's more what it wasn't what you were asking, but you might be also interested in UI testing. For UI testing, Xamarin have a different, separate paid offering called Xamarin UI Test or something similar, which you can use with a cloud set of devices where you build your tests on your machine, submit them to the Xamarin cloud, and then they run the tests on a bunch of devices, on hundreds of devices, and report back results. So you're not just doing UI tests on the emulator or your own device, you're running UI tests on hundreds of different devices from different vendors, different screen sizes. It's, I don't remember, I think it's called the Xamarin Test Cloud, but that's a totally separate offering, and it's pretty expensive too. Yes. Any more questions? I know lunch is coming up, but still. Yes. Just the mic, please.
If you already have some HTML things, can you include them?
Well, if you have a complete hybrid HTML application with phone gap and all that, it wouldn't make a lot of sense to use Xamarin. But if you have some pieces of your app that you just want to reuse, and they're already implemented as cross-platform HTML, yeah, you can put a web view in your Xamarin Forms project. It's the same thing with XAML and all, and a web view can host HTML, JavaScript, and CSS content. So you could include that in your Xamarin app as well. But if your whole app is HTML, you don't need Xamarin. Over there.
Thanks. In your experience, are there any additional hoops or hiccups submitting to the stores?
Hiccups what? What's that?
Submitting to the stores, the Apple Store or the Google Store? Or...
No. So both the Android and, well, on Android it's really trivial to submit anything to the store. So let's focus on iOS. There is a pretty simple process today for building, for creating an archived app in Xamarin Studio. You still need Xcode for one last final step of the process. So it is a little more complex than just using Xcode to produce the final app. But once you have the application package, submitting it to the App Store, getting it approved, no. I haven't seen any issues specific to Xamarin. Again, the whole thing is compiled down to native. I am not even sure the App Store testers have a way of knowing that you're using Xamarin. I mean, an engineer could deliberately find out, but the testers, I'm not sure they even know.
Thanks. Is it possible to build the artifacts on a build server running something like Jenkins without installing Xamarin Studio? Have you any experience
I'm sorry,
of
could you
that?
repeat the first part of that?
So I'd like to be able to build the application, build my Xamarin app on a build server, not in the IDE. So is it possible to do that on a build server running something like Jenkins?
Well, I haven't actually tried, to be completely honest. So I'm not sure, but I'll be happy to find out. I believe so, but I'm not sure. In any case, if you're building on a Windows machine, you will need a Mac build host, regardless. And I'm pretty sure, in fact, that if you are using a Windows machine, then you can just use MS Build. But you will obviously need the Mac build host. If you're using a Mac and you're using Xamarin Studio for development, I am not 100% sure there is a command line tool chain that doesn't depend on the whole tool's installation. So I'm just not sure, actually.
Okay, thank you.
Okay, I'm sure if we wait a few more minutes, then someone will have a question, but you're just feel free to come and ask me. Again, I'm going to be here throughout the day. I have another talk after lunch. So again, thank you very much for coming. Enjoy the rest of the conference. Thank you again. But I also know it's unreasonable to expect everyone to learn 3 different platforms and languages to target 3 mobile platforms. The other end of the spectrum, we have web or hybrid applications, and then you only, and I'm saying only in quotes here, you only have to learn HTML, JavaScript, and CSS, and you have an app, or at least a mobile website, that will look decent on most mobile platforms. And that's partially true for very simple applications. But as soon as things get a little bit more complex, you find yourself writing native code and adding plugins to your HTML application and building different layouts, different HTML pages, different CSS style sheets for different platforms. And so at the end, it might be a pretty bad mess anyway, even though you started out with a lot of shared code. And the other problem is the end user experience. And it's a pretty well-known story of how Facebook sort of decided to move away from HTML5 for their mobile applications and go with native. It's not supposed to convince anyone, but it does show that in particularly high-performance scenarios where a really good user experience is necessary, you might sometimes find it impossible to achieve the result with just HTML. And then as soon as you start adding native components to an HTML application, you start losing all the advantages of cross-platform development with HTML. And finally, Xamarin, which is the focus of our talk today, is at least designed to put you right in the sweet, proper spot of combining the best developer productivity, because you're using just one language and one development environment, and that's C# and Visual Studio or Xamarin Studio, and you're getting the best end user experience because the final application has the same performance, or at least almost the same performance, as a native one. Because you're not building HTML pages that show up in a web view, you're actually using the platform APIs, but you're doing it from C#. So that's the premise, that's the promise also of Xamarin, and that's what we're going to look at today. So the Xamarin approach, I also have another talk in the afternoon, and I'm flying home tomorrow, so if you got any questions, I'll be happy to help today. So let's just get started. My assumption, sort of, is that everyone in this room is a mobile developer in one way or another. Maybe you've already built a mobile application. Please, would you raise your hand if you have? Okay. Maybe you're planning to. Maybe someone's forcing you to build to build a mobile application. And even if you're building websites and you've got people on mobile devices accessing your websites, you could say you're a mobile developer as well. You have to cater for that audience as well. And what we're going to do is really see how you can leverage your existing C# and .NET skills, which I assume most of you have, to build mobile applications in a more familiar way than if you had to learn Objective-C and Java and the Android specifics and the iOS specifics. And of course, code sharing is a pretty big advantage of using C# with Xamarin, as we'll see throughout the talk. So what we're looking for really is kind of the combination between the best user experience you can get and the best developer productivity that you can get. And there's a number of solutions across the spectrum here. So on one end, you've got native applications. You can build an iOS app in Objective-C and Xcode. You can build Android apps using Java and Eclipse. You can build Windows Phone apps using C# and Visual Studio. And then your developers are in a pretty bad shape, and you, as the developers, are in pretty bad shape. You have to learn 3 totally different platforms, paradigms, and environments. And you're dealing with unique problems on each platform. Plus, you're probably not sharing any code, unless you're willing to do C++, in which case you can share code, but then it has to be C++ code. So that's one option, native development, and you get a pretty good user experience on the other hand, but developers are suffering pretty badly. And I'm saying this as a developer who actually built iOS and Android native applications, so I know the tools, I know the languages. Hi, everyone. Thanks for coming. Adorable as these monkeys are, we have a different agenda for today. So welcome and thanks for coming to this talk on Xamarin, C# everywhere, using C# to build Android, iOS, and Windows Phone mobile applications. My name is Sasha Goldshtein. I live in Israel. I'm the CTO of a company called Sela Group. I'm a Microsoft MVP, and actually I'm a C# MVP. And up until a year or two ago, I was doing lots of stuff totally unrelated to C#, which is my MVP expertise. But now that Xamarin has become available and more popular and more widespread, I'm actually doing lots of C# work in non-standard environments, such as the iPhone and Android devices, as well as other mobile platforms. So in this talk, the plan is to spend the next an hour and a half or so building a couple of mobile applications using a couple of different approaches, but in both cases sharing as much code as possible across all the platforms that we're going to target. And we'll start with a more traditional Xamarin-based approach, which has been available for about 3 years now, and you can use it to achieve pretty perfect code sharing, 90–95% of code sharing, but you still have to build a different UI for each platform. But then we're going to talk about a new technology that Xamarin just announced a couple of months ago called Xamarin Forms, which lets you share 100% of the code in many cases, including the UI layer itself. So you can build UIs that will automatically adapt to whatever platform you're running on. We'll talk about the advantages and disadvantages of Xamarin as well, how to handle platform differences. So there's a bunch of stuff in this talk, some demos and some theory. If you have any questions, please just feel free to ask. And of course, at the end of the talk, if you have anything else you'd like to discuss, I'll be here. Or by using shared libraries, which are, in our case, PCLs, Pickles, Portable Class Libraries. I hope you've heard of the term. Portable Class Libraries are libraries that contain .NET classes, which can be used from different platforms. So you can use a PCL from iOS, from Android, from Windows Phone, from Windows 8, from a WPF application, from ASP.NET applications. It all depends on the set of platforms that you configure your PCL to support. So by using PCLs that are compatible with Xamarin, you can build shared logic, shared components, and you can also find lots of shared components existing online on NuGet, for example, and you can use them from all your different platforms, from all the different applications. And so again, the holy grail here is where you just have these little tiny projects for iOS and Android and Windows Phone and Windows 8, which are all accessing the same big library, which contains all of your actual code. So you only have these tiny projects that produce a build you can install on devices, but your code lives in a shared component, in a shared library. And that can pretty much be our reality with Xamarin. And so with Xamarin, you can bring your C# code to roughly 2.6 billion devices. And this includes iPhones, Android phones, Windows PCs, which could already run C#, of course, and Macs as well. It's not something we're going to cover today, but you can also use Xamarin to build Mac, native OS X applications, as well as iOS apps. Again, using C# and sharing lots of the logic between the platforms. And so 2.6 billion devices is a pretty appealing proposition. And let's just talk a little bit about how Xamarin works before we get to a demo where I build a simple Android application using Xamarin. And then we'll go to iOS as well. So the idea is you get 100% bindings to the native API, provided again by Xamarin, provided by the means you're writing fully native applications, which are compiled down to the target platform, not running as HTML and JavaScript, but you're writing them in C#, which is pretty nice, considering most of us are C# developers. You can use your favorite IDE, and having worked with many mobile development environments, I'm pretty convinced at this point that Visual Studio is the best IDE ever conceived and built. And so you can use the Visual Studio Designer to design the user interface. You can, of course, use the editor and any plugins you have, ReSharper or whatever. And you can use the Visual Studio Debugger to debug mobile applications running on an iOS device or running on an Android device, running in a simulator, an emulator, and so on. You can access 100% of the native platform APIs with Xamarin, which is what makes it so different from HTML apps, from HTML platforms like PhoneGap and SenchaTouch. Using Xamarin, you have 100% API coverage. So your C# code can call exactly the same APIs that a native application can call. So if you find a snippet of code on Stack Overflow saying, to do this really subtle thing with the accelerometer on an iPhone, you have to call this function, and the code example you get is an Objective-C, you can use that. You just write the same thing in C#. You use a different syntax, but you use the exact same libraries and the exact same APIs. And so far, Xamarin has pretty much lived up to the promise of delivering full API support the day a major version of iOS or Android was released. So as soon as iOS 8.0 was finally released, Xamarin also released the same day support for all the iOS 8 APIs. And this is something they've been doing pretty much for the last 3 years. And finally, you can share code, of course, across platforms, assuming you're building a multi-platform, a cross-platform application, using shared code, using shared links to C# files, which I would probably discourage,